Hello, everybody. Welcome to the November meeting of the Mississippi PowerShell User Group. Tonight, our guest is Matthew Reynolds. He's a Microsoft Premier Field Engineer, and he's going to present on a topic from the PowerShell Deep Dive book that from the chapter he authored. He's going to talk about writing scripts that scale. So stick around after the meeting. We've got a book giveaway that we're going to give out a copy of a Sapien book, Windows PowerShell 2 TFN. So, I don't know, Matthew, ready to take it away?
Sure. Audio still okay?
Yeah, sounds good.
Yeah, I can't tell if the video is on or off. My webcam's going crazy. The last time I looked at it, though, I looked like a ghost, which was interesting. So I'm your ghostly presenter for the evening.
Let's see.
Well, good evening, folks. I'm Matt Reynolds. I work for Microsoft's Premier Field Engineering Group. You probably know a few of my colleagues, like Ashley McGlone. He and I work together quite a bit. And my focus with Microsoft customers and kind of the whole IT space in general is I want people to have good experiences with software, particularly Microsoft software. I want people to have fast machines. I want people to be able to, walk up to their Windows 8.1 tablet and, turn it on and be instantly logged on and responsive, instant on machines, quick logons, and that goes for server-side experience as well. So I'm kind of a performance guy these days, and to that end, there's a lot of scripts out there that don't perform so well, and so I wanted to get the word out there about one way to write scripts that scale really well. And I guess does anybody need to ask a question right off the bat before I get into what I mean by scripts that scale? I have to remind myself to stop and ask questions, because once I get going, man, I'll be. You'll have to remind me to slow down.
No questions on that, but there is. Were you trying to? Did you say you had the webcam on?
It was on, and then I tried to turn it off at one point, and now it's going crazy. So I have no idea what it's doing now.
Well, we can't see you now. It'll be all right. When you start presenting, we'll just merge that in. But also, as far as questions, we can. We'll as more people join, we'll mention in the chat room that if anybody has a question, they can put it in there, and Mike or myself could probably jump in and ask. I mean, it'd still be good, if you want to stop and ask throughout, but
yeah,
you don't have to worry too much.
But feel free to interrupt me, and
okay.
I'm not picky. So, what do I mean by scripts that scale? There's a lot of different aspects to scalability, whether it's, CPU utilization, disk utilization, error handling. But the particular aspect that I'm interested in, and I think that we often get wrong in the examples that we give out in the community, is scaling over large data sets. When you have a number of things, you're going to iterate over a bunch of things, and there's a kind of a dangerous way to do that and a safe way to do that. And to set the stage, use a metaphor. Let's say that your job, the task that you needed to accomplish, this is a real life job, not a scripting job, is to measure the amount of water that flows through a particular stream over the course of a day. Now, one way to do that, a really terrible way to do it, would be to construct a huge water balloon and try to redirect all the water from the stream into the water balloon, and then at midnight try to measure the volume of the water balloon, and there you go. Now you know how much water went through the stream that day. And I think the negative consequences of that are fairly self-evident when you put it that way. One, you're disrupting the system. Two, you're creating a lot of work on the back end, and three, it's fragile. It doesn't scale. For example, what if the task changed from being measure the amount of water over the course of the day to measure the amount of water over the course of 2 years? You couldn't build a water balloon big enough or strong enough to hold that much water, and eventually that approach is going to fail. So the other approach is to have some kind of a sensor that's in the stream that measures how much water is going past at any given time and recording that data somewhere. And then by aggregating that data, you can answer questions about water volume for a given day or a given year or a given week or whatever the case may be. And you're not interrupting the system. You're creating less work on the back end, and it scales to any degree that you might want it to. So having thrown that that metaphor out there, let's talk about how that plays out in the scripting world. Going back to this metaphor of the water balloon and the stream, what does that mean from a PowerShell standpoint?
Sorry, can you zoom in just a little bit?
Sure. Does that help? Just made text a little bigger?
Yeah, that looks better for me. Anybody else have any issues with that? Does that look good?
We got an "it's good" in the chat room.
Yep. Yeah, so I think it's good.
Okay. So, what does this water balloon stream thing mean in terms of scripting? It means that if you try to hold a bunch of stuff in one place, eventually you're not going to be able to hold any more stuff there. That's what it means. So if you do a web search for the terms PowerShell and out-of-memory exception, the number of hits that you get is just astonishing. The number of forum posts about, hey, I was writing this script and then I tried to run it, and the third time I ran it I got out-of-memory exception. There's definitely a persistent issue with the way we tend to write scripts today, and with scalability, particularly memory scalability, and being able to fit enough objects in memory to iterate over them and deal with them. And so the stream versus the water balloon in scripting is about writing scripts that perform well and that scale well over any data set, and also work well with remoting, because in remoting you have additional constraints, like the transport back and forth between the client and server, as well as the memory limits on the remote run space. So I'm going to highlight a fake PowerShell line here, line 11 on my screen for those of you following along. Who's ever written a line like this? Well, we all have, right? This is classic PowerShell 101. Dollar things equals get things. So that's fine, that's lovely. But what if there could be a lot of things? What if there could be 100? What if there could be 1,000? What if there could be 20 million? That's where you get into the scenario of popping water balloons and out-of-memory exceptions and scripts that don't scale. They may work fine in the lab or work fine while you're working on them, but not at enterprise scale or cloud scale. So that's kind of the anti-pattern. But that's such a fundamental thing that we all do. It takes a little bit of thought to get to what is the alternative. The next example that I want to give is on line 14 for those of you playing along. What do you think? Well, I guess we've got a lot of people on mute, so you could either pipe up or do IM. Is this a water balloon or no? Uh-oh, I lost my remote desktop session. All right, it was an easy guess. Yeah, Francois, there you go. So this is also a water balloon. It's exactly the same water balloon as before, only we didn't give it a name this time. So we're creating this dynamic collection in memory for get all the things, and then we're going to pass them as one big chunk collection to invoke thing. So that's just as fragile as the one before. So now, that's a bit abstract. What I want to do now is show you the water balloon in its native habitat. So this is a line that anybody would write, right? Log entries equals import CSV to some big log, and then maybe we wanted to get a particular column out of those logs, this name column, and so then we'll use select object to iterate over those. It doesn't matter the particular commandlets, it doesn't matter the particular syntax. What matters here is that we're putting all the log entries into one big balloon. And let's see what effect that has on the system. So I'm going to run this in a volunteer PowerShell session. And as that runs, I'm going to open perfmon on my server, and we'll see what happens over time. In fact, this is the red line. Can people see that okay? The perfmon? Yeah, okay, good. The red line is available memory on the server. The green line is the private bytes of the PowerShell process. And there's a natural inverse relationship between the two. The more memory that, or the more virtual memory, private bytes that the PowerShell process consumes, the more physical RAM is consumed and the less is available for the rest of the system. So, and this log isn't all that big. It's only about 500 megs. In fact, all it is I did a get child item recurse of the Windows directory. So it's just a bunch of entries describing all the files in the Windows directory. So you could easily have IIS logs or other types of logs that would be, much, much larger than this. And if we let this go for a few more seconds, we see that things just get worse and worse. The PowerShell session continues to consume more and more memory because we're building this huge water balloon. And the available RAM on the system continues to decline throughout. What do you think is going to happen when the red line gets to the bottom? Out of memory. So when we say out of memory, there's a few different kinds of memory to think about. And each of them is important when you're designing scripts and want them to scale. One limit is the amount of memory that one process can address. And in this case, it happens to be a 32-bit process, so it's limited to addressing about 2 gigs of RAM in user, 2 gigs of memory, I should say, in user space. And if it tries to address more than that, it will fail. If this were a PowerShell remoting session, it would be limited to, 50 megabytes or 150 megabytes, so we would have failed already. Another kind of memory is to think about limitations on, and what happens if we run out of it, is RAM. And obviously we're getting very low on RAM here, but the system hasn't crashed, and that's because we're not just limited by RAM, we're limited by RAM and page file and some other corner case things. Well, not really corner case things, but we're limited by RAM and page file and some other behaviors of the memory manager. So in this case, if there are if other processes, for example, had large working sets, we could start paging those out. In this case, I don't think any other processes had particularly large working sets, or maybe they're already paged out. And things just get worse and worse, so we're paging more and more. The server is less and less performant. If I try to do things like switch around to different applications, there we go. Or if I try to do additional tasks, if this is some important server, it's gonna, it's bogged down. It's not feeling that well. Eventually, this script will actually fail with an out-of-memory exception. I may not wait long enough for it to fail. Should be here in the next couple of seconds. And that's, again, because it hit one of those several limitations. And in this case, it would be the 2 gig process limit on 32-bit processes. So pretty destructive to the health of my system. Rather than waiting for that to fail, I'm just going to cancel it and move on. Now that I stopped that script, the PowerShell session gave up that huge chunk of memory, that huge balloon that it had created. And available RAM on the server shot back up, thankfully. Now, to reproduce that issue, I didn't have to do anything exotic. All I had to do was write a script like we would all normally write one, right? Things equals get things. In this case, it was log entries equals import CSV, blah, blah, blah. So that's the anti-pattern. Or further examples of the anti-pattern. Now let's talk about how we could do that in a scalable way. So I'm going to use the same 2 commandlets, import CSV and select object, but this time instead of storing the results in any kind of temporary collection, whether in a variable or not, I'm just going to stream the results from import CSV to select object. So same task, same outcome, or same desired outcome, but let's see what the performance characteristics of that are. So first of all, you can see it was quite fast. It's already returning results. And second of all, if we go to perfmon, let's watch those lines for a few seconds. So we're dealing with exactly the same log file. We're doing exactly the same task with it, but our memory usage is flat. And our memory usage is flat for the same reason as we're getting results right away. And most of you have guessed that the reason is because we're processing items one at a time. So the way the pipeline works here is import CSV, creates an object, and passes it to select object. Then effectively the process block of select object does something with it. In this case, pulls out the name property and emits it. And then we move on to the next one. So by processing one at a time, we became much, much more scalable. And in fact, not just more scalable, but it's completely changed the dynamic. We've gone from being limited by the log file size to we could process any log file size with this. It could be a terabyte log file. The memory footprint would be exactly the same. All right, I'll stop this one. So when I introduced this topic, or when I first sort of started to figure it out myself, the first kind of big question in my mind was, well, people always told me that pipelines were inefficient, that pipelines were slow. And you'll often see examples on, user groups, or somebody will post like the classic example of, get content, and then they're piping it to, where object and doing some filtering, and then piping it to something else, and then eventually coming out with some result, and it takes a long time. And they'll say, well, why is this slow? And the answer is always, well, it's because you use the pipeline, and what you should do is this, either get content or stream read or read all lines or whatever you prefer, and then for each. What people are implying that the for each loop is faster than the pipeline, which isn't necessarily true. What's really slow in that case is get content and the way that it deals with the data. And if you change it to get content or stream read or read all lines, into some collection and then iterate over that collection with for each, well, you've just created a water balloon. So what we need to do is find ways to do these sorts of tasks that are both fast and memory efficient. And I'm going to show some examples of that next. Before I do, what questions have people got up to this point? All right. So I'm going to do the same task 3 different times, 3 slightly different ways, and we'll use measure command to see how fast they were. So first of all, I'll run the task without measure command so you can get a sense of what it is. So all I'm doing here is kind of the classic pattern. I'm saying for each file order in get child item Windows, and then spit out the full name. So I'm similar to the task before. I have a bunch of items, and for each one I'm going to do some task. In this case, it's a very simple task of pulling out a property. And if we run that, we would expect to get a bunch of file names, and we will. Oh, of course, we get the, because I did Windows, there's a few paths I don't have access to. Thank goodness for non-terminating errors. I think this is whenever I get really frustrated, or somebody that I'm teaching gets really frustrated with terminating and non-terminating errors, I always come to this. This is the great example of why we have non-terminating errors. Okay, so there you see it works the way we'd expected. It pulls out some file names from some files. So now let's figure out the performance of this. And so we'll do measure command And this VM's been a little sluggish this afternoon, so hopefully we'll have time to let it run through. If not, I've got some pre-run results from earlier. Okay, so we know it's still trying to enumerate all the files, so it hasn't even started spitting out the properties yet. And once it gets to the point of having all the files, which is probably around now-ish, then it's going to start spitting out the properties, and we'll see how long that takes. Okay, so total seconds is 27. So that's pretty good. So this approach was fairly fast, especially considering this machine has a relatively slow drive, but it was dangerous because it created a water balloon. See, right here. This is a huge water balloon, and if there were more files than I was expecting, or more whatevers, more widgets than I was expecting, I could have a scalability bug on my hands. So now let's do kind of the alternative, which is, or actually no, before we do that, I want to do this one. So in this case, we're going to do exactly the same command. It's still a water balloon, but instead of doing the property style access like we did on line 13, we're going to do a commandlet style access. So it's the same task, just accomplished using a commandlet as opposed to the dot approach. So let's measure this. So this is still a for each loop. We haven't introduced a pipeline, or at least we haven't introduced any piping. Those two can get blurry. Who thinks this? Any guesses on whether this is going to be faster or slower than the dot syntax? Okay, we got a same, a maybe, a slower. Okay. I think we can tell already that it's been, to me at least, it feels like it's been more than 27 seconds. And in fact, this one is slower. There we go, 47 seconds. So it took, almost twice as long. And this is still the supposedly fast water balloon pattern, where we collect all the items first and then iterate over them. The only difference is between the dot syntax and the commandlet syntax for doing the task, which in this case was pulling a property name off. So I think what we've learned here is that piping isn't necessarily expensive. What's expensive is commandlet binding and just the overhead of commandlets, because in commandlet binding we do all kinds of cool stuff like validate parameters, and there's some overhead associated with that. So when you see people give examples of iterate over the file, here's a fast way, here's a slow way, and it usually gets blamed on piping. Often it's not actually because of piping. Often it's because of something else, like the difference in performance between select object and dot full name. So now let's do an example. So both of those examples were bad for scalability. Either of one of them would blow up if I had more items than I expected, or if I was in a constrained memory run space like remoting. So now let's do the same task with the same commandlets, but with piping. So in this case, on line 25, the output from getChildItem will go to, is piped to select, oops, I forgot to add the measure object, or measure command. So the output of getChildItem is piped to select object to do the same task we've been doing all along, which is pull off a property of an object. Now, the fact that we're doing a dumb task like pulling a property off of an object is not the point of this. That's just a stand-in for whatever real-world task you would really be doing. The point of this is how can we do things in a scalable way? You'll notice because we're piping here, we should be processing these one at a time. So if we check over in perfmon, we can see, yeah, very good. Our memory utilization is completely flat. It's not climbing up over time. And then once it finishes, we'll compare our performance. 42 seconds. So it was slower than the first example, but actually faster than the second example, which was a for each. So the takeaway for me, the takeaway from this is that pipelines aren't necessarily slow, or piping isn't necessarily slow. Commandlets can be slow, commandlet binding can be slow, but a well-done pipeline, what tiny bit you may lose in terms of speed, you can gain, assuming you've done it properly, in scalability. Now, to be clear about something here, I'm not saying that writing pipeline, piped commandlets is the answer to everything. What I'm saying is, when we script, when we give examples, when we write scripts that we expect to scale to the enterprise or to the cloud, we should be thinking about scale. Every time you write $things equals get things, you should be thinking, wait, this is dangerous. Is there a scenario where there could be, a lot of things? So it's not about pipelining per se. It's about thinking of your scripts in terms of processing one item at a time via whatever means, and thinking about your scripts in terms of scalability. Another kind of myth that comes up a lot, and I find this from kind of PowerShell newbies, where they'll say, oh, I don't like the PowerShell way of accomplishing this task, where they think the way to do something, they think that they have to use piping all the time, and particularly they think that they have to use where object to filter things. So in this case, we're calling getChildItem, so we're getting all the files in Windows again. This time we only want the file netlogon.dll, and we'll see how long that takes. So who can tell me what's terrible about this example? It has nothing to do with memory utilization this time. No volunteers on that one, huh? What's terrible about this example is, there we go. Yes, we should filter as far to the left as possible. We should have implemented our filter on the getChildItem commandlet, just as it does in the below example. Now, this doesn't have a whole lot to do with memory scalability, so why am I bringing it up in that context? Well, the reason is, whenever you start talking about pipelines with people, you get strange scenarios like this, and people think that they have to use where object, and that's absolutely not the case. You want to filter as much as possible, as far left as possible, so that whatever iteration pattern you use, whether you get pipeline or other, has less work to do further down the line. So just for the sake of comparison, here we are at the difference between those two was 44 seconds versus 6 seconds, so pretty dramatic there. That's all a bit abstract. We're talking about things like virtual address spaces and private bytes and get things when there really is no get thing commandlet. So what I want to do next is talk about this in the context of a more realistic, more complex task, and some of the trade-offs that you have to make in order to process things one at a time, as opposed to collecting them all in water balloons. Before I do that, again, I always have to remind myself to slow down. And anybody want to raise any questions before we move into that? Okay, fair enough. So this example comes from a real customer scenario that I had. I've actually had this more than once, where somebody needed to audit their Microsoft DNS servers to figure out what queries were being made. And there's a couple of scenarios here. One of them was an online retailer had done some advertising, and there were specific DNS names advertised, as part of the advertisement. And so they wanted to know, which of these were getting the most hits. In another case, in large enterprises, there's also been the case of we've got a bunch of records in our DNS zones, and we think we don't need a bunch of them, but nobody's sure, and nobody's willing to delete them because we don't know if something somewhere might be relying on it. So all these cases those are both good examples of where we need to take some external data where there's a lot of it, like a DNS server debug log, and parse it in a way that's scalable, and then also do processing on it that's scalable. Do some kind of aggregations or some kind of logic in a way that's scalable as well. So we'll walk through this. Just setting my log path. Uh-oh. Oh, it's because I'm in... I F8'd it, so it doesn't know what PS script root is. Okay, so here's what not to do. In fact, I commented this out because I wanted to make sure that I didn't actually run it. There are 3 bugs in the highlighted section. Does anybody know what any of the? Does anybody want to take a stab at identifying any of the 3? You got pretty good odds. There are 3 available. It's the last one that's tough. Too scary, huh? Okay, so here are the 3 bugs. The first scalability bug is this one, which is the same anti-pattern we've been talking about all along. This one takes all the lines in the DNS debug log and puts them in a water balloon. That's fine if you have a small log. It might not be so fine if you have a large log or if you're running in remoting or under some other constraint. The next bug is the next line, which basically does the same anti-pattern. We've taken our raw log lines and parsed them using this function that we'll talk about later called convert from DNS logline, just a parsing function, and taken all of those objects and again stuffed them in a fragile water balloon. So those are our first 2 bugs. The third bug, the scalability bug, is here, where even though we're using a pipe, we're using group objects, and group object by default keeps all of the entities that were piped to it. In other words, if you're using group object to, say, count things by query FQDN, so I want to know how many queries were for this FQDN, how many queries were for this FQDN, by default, it not only does that, but it saves a copy of each one of these query objects, the parsed logline objects. And so that, again, is a gigantic potential water balloon. So we can rewrite this, avoiding all 3 of those scalability bugs, like this. Okay, we're going to use get content, or you could use, a .NET method, whatever you prefer, and pipe that to this convert from DNS logline function. And what the DNS logline function does is, again, it just parses the individual lines. And just to give you a sense of what that does, I'll run this for a bit. Maybe I'll send that to Outgrid View. Oh. No, that's not very friendly to Outgrid View. Do it this way. Forgot their hash table, so Outgrid View doesn't really know what to do with them. Presenting from home, by the way, so you'll hear some wildness in the background. That's all good. So what you see here is a series of objects that represent the log lines from the DNS log file. And so we've taken each field in the log file, like opcode and time and blah, 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 and parsed it. And then from there, we've created individual key value pairs. And we've also calculated some new ones, like date time, which is extracted from the raw data. And so basically, we have one of these hash tables for each object, or for each line in the log file. So that's what convert from DNS logline does. The important part here is how convert from DNS logline does it. It does it using a proper process block, so it gets memory scalability. So let's run it again. This time we'll run it with group object. And while that's running in the background, I will talk about how the function works a little bit, or at least the relevant parts of it. Notice that, so in this case, we've eliminated all three of the scalability bugs from the earlier case because we're only processing one item at a time, and we've passed the no element flag to group object such that it doesn't save copies of the original objects. It just does whatever counting and grouping it's going to do to report back. So in this case, it's telling me that there are 34,000 entries, and for some reason it didn't like the property query FQDN. Normally they would be broken out by unique query FQDNs. Like there were 30,000 for this and 1,000 for this. But you know how that works, so we won't worry about that. So the no element parameters important for scenarios like this where you're using group object to do some kind of aggregation for you. Now let's talk about why convert from DNS logline is scalable and how what we can learn from this in terms of writing functions that do scale well. So first of all, we're set up to take input from the pipeline, so that's kind of job one. And another good trick when you're taking input from the pipeline, but you think you also might take input on not in the pipeline, like from a command line, and you want to allow for multiple objects, is to define your type as not a singleton. So for example, here we're saying, even though we're only expecting one item at a time from the pipeline, I've specified this as a string array, not just a string, because if somebody wanted to call this just from a straight command line, I would want them to still be able to pass in multiple objects. And then we split that apart in the process block. But of course, if they were calling it just straight from the command line, we're assuming they are only passing in a few things. Otherwise, it wouldn't be very scalable because this would be huge. So we're going to make the assumption that if someone's going to use this against a large data set, they'll use the pipeline. Okay, so here's our begin block. This is task specific. This is the gigantic regex that you use to parse that particular log file. So that's task specific. We don't really need to talk about that. But this is interesting. You know what? Let's come back to that. Let's go to the process block. So here within the process block, I have a for each block. That's in case I was called on the command line with multiple input items instead of on the pipeline. And then for each item, we do our work. You know, we apply the regex, blah, blah, blah. We calculate some properties, and then we emit that object. So nowhere in here do we create any water balloons. We process one line at a time. We spit it out to whomever is going to consume it further down the pipeline. So that's simple enough. But whenever you get into a real-world task, as opposed to just something abstract like I was showing earlier, other stuff immediately creeps up. Like you'll find that, oh, well, I don't just need to parse them. I also need to count them. Or I need to, at the same time as I'm parsing them, I need to keep track of how many had this value or something like that. Now, the tempting way to do that would be to collect all the pipeline stuff in a variable, and then in the end block, do your real work. But by doing that, you've created another water balloon. So the way that I would suggest to approach this is try to think in terms of how can I answer the question that I want to answer without ever seeing all the objects at the same time. For example, I want to count them. How would I count them without seeing them all at the same time? Well, I can count them one at a time. And similarly, you can figure out averages, you can figure out sums, you can do all kinds of tracking. You can track by unique things like using a hash table where the unique value is the key and the number of times you've seen it is the value, like an integer value. All of those those ways are, you can do the kind of extra processing that you might normally do by non-scalable ways in a one-at-a-time pipeline type fashion. So that brings us back up to these guys. Why did I create these guys in the begin block? So these are just integer counters. I want to know how many lines I've processed and how many of those were packet lines. It's a subset of the lines. And again, I don't want to collect them all in an array and then do .count, because that would be a water balloon. So what I do instead is I just create these nice integers, and then each time through the process block I increment them. So here I'm incrementing one of them, and then here I increment the other one. And then at the end, I have these lovely integers that I can answer whatever questions I had wanted to answer, as well as parse the things like how many were there, without ever having collected them in one place at one time. Okay, questions about that one before we move on? So I just said that you can, with a properly written process block, and maybe a few hash tables here and there and some integer counters, you can do answer most of the questions that you might want to answer about a data set without ever having the whole data set in memory at one time. And that is true. We just saw that it was true. But there are cases where it's cumbersome. There are cases where you want to merge data over time. Like, I'm going to parse the log from this one server, and then I'm going to parse the log from the other server, and I want to be able to sort of merge those two data sets. And, well, how would I do that in a pipeline sort of way? That seems really involved. Or I want to do some really complex sorting that's sort of multi-factor, multi-dimensional, and it's just too hard to answer with some integers and maybe a couple of hash tables. Or you want to expose the data to other consumers to do further processing other than PowerShell. Like, you have somebody wants to build a report in Excel of your DNS queries or whatever data you're working with. So in all of these cases, I start to lean toward, let's just put the data in a database, and that can be our way to scale it, because databases, unlike scripting languages, know how to deal with this stuff. So with a script, you have to be very careful, right? Like, you have to use use a very specific set of functionality in a very specific way in order to be scalable and work within those constraints. Well, databases are made for big blobs of tons of data and tons of records and being able to do all kinds of math, and they abstract away from you the complexity of paging data off of disk versus caching it in memory, and keeping the hottest pages in memory and all that sort of stuff. Databases know how to do all that stuff, and as scripters, I think we can take better advantage of that than we often do. So here's an example. I've got SQL Server local DB. It's an edition of SQL Server installed in here. It comes with Visual Studio. You could do the same thing with any other database. And I'm going to replace that log path again. Oops. All right, so you recall in our in this function where we parse where we do whatever task we're going to do. In this case, it was parsing a DNS server debug log. We created an object to just emit down the pipeline, not having any idea who might consume it or what they might do with it later on. In this case, it just happened to be a simple hash table with some key value pairs. If I want to put that stuff in a database, I need to think of it in terms of some structure. it's harder to change a database schema on the fly than it is to add and remove properties from a PowerShell object. So once you've kind of settled on what your object looks like, okay, I really care about datetime, and I really care about remote IP address, and I really care about query FQDN, then we can pretty easily just go create a table in a database with those columns, and check if this is already here. You can pretty easily go create a database with those columns, and there are several ways to do it if you're not familiar with database stuff. One is to use Entity Framework, which will create the database for you based on your object model. You have to write a little bit of C# for that. Another is to just go into SQL Server Management Studio or Visual Studio and design the table visually, like say, okay, here's my database, I want this column and this column and this column. Or another way is to script it and say, have a series of SQL commands that create the tables and the columns and so forth. For those of you that have been down this path, you're thinking, oh yeah, that's obvious, that's easy. For those of you that have not, you might be feeling a little scared right now. There's this gulf between like infrastructure guys and database guys, I think, in most environments. Like the Windows Server guys do not sit at the same table at lunch as the DBAs. Like, for some reason, there's just a cultural gap there. So if you haven't had the pleasure of doing some database 101 stuff, and you're terrified by what I'm talking about just now, I'd encourage you to play with it. It's good one, William. I'd encourage you to play around with it. It's pretty accessible. Like, I don't know the first thing about databases, but I've started creating databases for lots of my scripting projects because it just gives me so much flexibility and so much scalability, because I throw all the data in there, and then I have the database do all the hard work in terms of counting and sorting and whatever else, and it figures out the scalability, and I just consume a nice, friendly result. And again, there's several ways to go about building out your database, as I mentioned. In this case, we've got a database set up that was created by this script that creates the table and then tells it what columns it's going to have. And that script actually just came from once having done it manually in the GUI and then generating a script based off of that. So now let's get some data in there. Let's explore, what we can do with it. Oh, so we don't need this one anymore. So now I'm going to create a new function, or we're going to use a new function called export DNS logline to DB. This expects to consume the output of the DNS convert function. So in other words, it expects to receive hash tables with certain key values. And then it takes a server and a database name, and it issues the SQL commands to insert the properties and values of those hash tables into the database as columns and values. In this case, I'm using a SQL module from Codeplex that does called invoke SQL query, but there's a million different APIs for interacting with SQL, so this just happened to be the one I'm using in this case. So there's our function. Make sure that's defined. And again, this is scalable. It takes pipeline input, and for each one of those, it does the insert. So there's no water balloons here. Let's make sure that's defined. And then let's give it a run. So here we're going to say, we're going to use that same function as before, convert from DNS logline against this huge, well, it's actually not that huge in this case, DNS debug log. And then for each one of those, we're going to pipe it to this export DNS logline to DB. And hopefully, if all goes well, those should show up in the database. So let's run that. Let's take a quick check in perfmon to make sure this is really scalable and it's not creeping up with each line in the log. Yep, looks good. Our available memory is actually going up, and our PowerShell memory is staying flat. Okay, so now we've got all this data in the database. Or it's still running now, but we should have some rows already that we can see. So this will run for as long as it needs to based on the size of the file. But again, it's processing one at a time, so we know that some rows are already in the database. So let's go take a look. Here is my database. It's called DNS packets, and I'll say view data. That actually just brings me back to here. And there's my lovely columns like query FQDN and remote IP address. So essentially what I'm doing here is I'm taking my PowerShell object, because I'm always thinking in terms of objects, and just making it a row in a database table. There's a pretty smooth transition in most cases. Obviously some stuff doesn't come over, like script properties, but to make the round trip, if I pulled this back out, it wouldn't have any script properties. But for simple stuff, property bag type objects that describe something, this works really well. You can just go back and forth between objects and database rows. So then, of course, someone could do something fun like, let's go into Power Pivot. So I'm in Excel 2013 here, which is awesome. Okay, so we've got 38,000 rows so far. There's a bit of overlap because I've run this several times. And okay, that's good enough. Now let's use Power View, which is also an awesome feature of Excel 2013, to answer some questions about this data. Okay, so here's my DNS packets table, and here are the line items on it. So let's take, I'm definitely interested in remote IP address. I want to see where most of my queries were coming from, because my DNS server was really busy, and I want to know who was hammering it. So I'll add that. And maybe I'll add date time so I can break it up over time. And then let's make that a... Oops. Let's see, I've done something wrong here. It won't let me switch to a line graph. Oh, here. Obviously, I'm not so great at Excel, but you get the point. People can build fancy charts, and I had some fancy charts earlier, but I can't seem to walk through the same process to recreate them. Try that one more time. So the chart was actually really fun. Not sure why I can't make it a bar chart. There we are. Okay, so now let's answer some questions. We'll do a bar chart for now. And so here we have what queries were made. What were the most popular queries? And there are lots of those values, so you could build a filter to only show the most popular ones. But what I want to do is get an IP address, and then let's just do a, we don't even care what the FQDN was, so let's just use a field like ID, and we'll do a count. And we can see here, based on this, that most of the queries actually came from the local machine. So there's some process on the local machine hammering away and issuing those queries. And then this 192.168.100.17 issued the next most queries. So if I want to further explore and say, well, of those queries that came from the local host, what was the FQDN? And I can see is actually a whole wide variety. The biggest one was this msdcs.ds.contoso.com, or the pattern this way is, for example, all of the queries from this 100.10 machine were the same, et cetera, et cetera. You can answer whatever set of questions you want to answer. Now, we could have individually answered each of those questions, whether it was unique count by FQDN or query count by source IP address. Each one of those things we could have answered using PowerShell directly. But each one would have been a separate pass through the data, and each one, we'd have to make sure we're doing it in a scalable way. And it's hard to share the results because your result is maybe a PS object with some properties on it or something. So in addition to the scalability benefits, one of the nice things about using PowerShell to put the data in a database is that you open the door to a whole bunch of other data analysis and consumption scenarios, including scripting. So I can still script over that data and do SQL queries against it or whatever right from PowerShell, but I also have the option of using Excel and all those other sorts of tools. That was a lot of words. So the takeaway here is don't make water balloons, make streams, and may we all write PowerShell scripts that scale to the enterprise and scale to the cloud and don't fall over. Questions?
Yeah, I agree. That was a really, really good job. Really
Wonderful.
Good presentation.
Is this my impression is that this isn't necessarily widely circulated information. What did you guys think? Is this sort of obvious, or is it only obvious in retrospect, or is it surprising?
Well, we got a few answers coming in, but yeah, I mean, I would say it was. I actually read your chapter in the book beforehand, so. But in retrospect, on reading the chapter, it was. It seemed like it was pretty obvious after I read it. So.
Right. Well, good. That's the point. See. All right. Well, I'm happy to hang out for a couple more minutes for any other questions that come up. Happy to talk more about any aspect of that, whether it's the proper use of the process block or more about SQL integration and some stuff that I kind of glossed over there.
And if anybody wants to unmute themselves, they're more than welcome to talk.
Yeah, I think the script I was showing Ron earlier is actually a water balloon, and the one thing I saw that I hadn't thought of before is storing the data in SQL.
Yeah, and it took me a long time to come to that as well because I didn't sit with the DBAs at lunch. But I wound up writing, as I was trying to write scalable scripts, I wound up, the pipeline stuff is easy. Let's just process one at a time. But as I wanted to do more and more complex processing, like, oh, well, I need to know how many of these and compared to those and cross-reference against this, my stuff was getting more and more complex, and then in order to get good performance, then I was having to come up with like caching, so then I had functions that were managing like, well, how much data is on disk and how much is in memory. And then at one point I was like, wait a minute, there's a set of people who have been solving this sort of problem for 30 years. Maybe I should just use their stuff. So I'm kind of a recent comer to the database world, but loving PowerShell plus SQL.
Yeah, I definitely enjoyed the presentation, and I appreciate you presenting for us.
Okay, somebody had asked if they can get access to the examples. I think all of those same examples are part of the downloadable content for the PowerShell Deep Dives book. So that'd be I think the first place to go. And then if you have follow-up questions or whatnot, feel free to hit me up. What's the best? Probably Twitter's the best way, at Matthew MWR. Well, I'm happy to see so many positive responses on the IM. That's a good feeling. So, oh, there we are. Thanks, Mike. So, I guess if there aren't any other questions, I'll turn it back to Mike, I guess, to close things out.